Hello everyone. So let's talk about triangles, and in the subtopic it's similarity and Thales theorem. So triangle is a very interesting polygon to study in the first place. I mean, why study about polygons, or why study about a triangle in the first place, or what makes triangle a very special polygon to study? So these are some questions which might pop out, and the answer is this. So you see, in any polygon you take, say for example, I take a quadrilateral, which is a polygon of four sides, which might be like this, and naming them. Now I draw a diagonal in between these two vertices, or DB or AC is called the diagonal of this quadrilateral. And now you look, this diagonal actually separates these quadrilateral into two triangles, not necessarily equal, but say for example two triangles. Now A B D and then D B C, right? Oops, so it's D B C. Now you see, if at all I want to study about this quadrilateral in particular, it is now reduces to two problems to study about this triangle first and this triangle next. So you know any quadrilateral now could be now divided into two triangles, and you can study about that two triangles, which means that you are studying about the quadrilateral, or let's say pentagon or hexagon, or whatever n-gon you have. You still can reduce that n-gon to many triangles, and then you study about those n triangle, maybe angles, sides, or whatever, and then you will be able to know many much information about the n-gon which you have. So triangle is such a powerful polygon to study. And now we look at similarity and Thales theorem. So many people prefer to study Thales theorem at the first place and then come to similarity, but let's try to change few things. We'll study about similarity, and with those similarities you will be able to look at Thales theorem in a very easier way than the expected things. So let's get started at the first place. So when do we say two triangles are similar, right? So I mean, what do we mean by similar at the first place, right? So we say similarity. So these are like identical twins, right? So they are two different things, but they are the same. So we say two triangles are similar if their corresponding angles and their corresponding sides, corresponding angles are equal. We say their corresponding angles are equal and corresponding sides are in proportion. So there comes a question, what do we mean by proportion, right? So let's say a triangle ABC, right? So we have a triangle ABC, and we have another triangle, maybe let's name PQR. So assuming that these two triangles are going to be similar, okay, so what does that mean? This triangle ABC is going to be similar to triangle PQR, is that the corresponding angles are going to be equal. So if I say this A is going to be, say, some angle, the same measure is going to be angle P or Q or R. So the order now becomes important, right? So now this A now corresponds to this point P, or this angle A corresponds to the angle P. So nevertheless you can also match the other two angles. Say for example, I can even say that this B is equal to this angle, B is equal to this angle R. Why not, right? Or this angle B can also be equal to angle Q. This is just an assumption at the first place, right? And then automatically what happens, this angle C will be equal to angle Q. So what happens, assuming that these two triangles are similar, what can we infer from these two triangles? This is the thing which we are trying to say. So we say two triangles are similar. So we say this triangle ABC is similar to triangle PRQ which means that their corresponding angles are going to be equal and the corresponding sides are in proportion. So which means that this side length AB will be in proportion to the side length of PR. Say if I assume this is going to be some 2 centimeter units, this might be again in 4 centimeter units, or you can double or triple or whatnot, right? Or this could be even a shrinked version. So yeah, so their corresponding sides are going to be in proportion, right? The next thing, so when do we say, or how do we say, when these two triangles are, or how do we say these two triangles are similar? So we have many criterions and we will discuss these three. So we say angle criterion. As we discussed earlier, if three triangles of one triangle are equal to the three angles of the another triangle, then we say that the triangles are similar. Say I take a triangle ABC, this first place, ABC and DEF, and now say angle A and angle D. Angle A equals angle D and angle B equals angle F, and automatically what happens, angle C will be also equal to angle E. This is a very nice question of asking how. This happens automatically. This actually happens automatically. So I guess we can pause the video here and think, why does this happen? This is a very simple thing you might have learnt in your lower grades. So according to this angle sum property, right? So this happens due to the angle sum property, right? So if angle A and angle B and angle C form a triangle, then the sum of these angles will be 180 degree. So of course this angle C will be actually 180 minus the sum of this angles A plus B, right? So similarly this D and F will be equal. Similarly this D and F are same as angle A and B. So definitely angle E will also be equal to what? This angle C, right? So you not even you want to study about all the three angles in this triangle, but you can even reduce this criterion to AA criterion, right? So if at all you say that AAA criterion, you can even simply say that if at all you find any two angles of these two triangles are equal, then automatically the third angle will be equal, and therefore by AAA criterion these two triangles are equal, right? Fine. So this is one criteria. What happens if not all the three angles are given, or just only one angle or two angles are or one angle is given, or if at all I say these three angles are equal, I say this triangle ABC is similar to triangle DFE, because the order also matters here, right? Why not DEF? So if at all I write DEF, what happens is that this angle B, which is at the middle, should be equal to angle E actually, but if at all I write in that order, but that doesn't hold true here. So angle DFE triangle DFE should be the correct order. Let's come back here. So if at all I say triangle ABC is similar to triangle DFE, then I should actually also say that all the line segments which make up these two triangles are in proportion, right? So which means that I can also infer that this side AB is in proportion to side DF, or in proportion, which means that they are in the same ratio. AB and DF should be equal to BC, this side BC, and FE or EF, whatever. I mean, it's just a line segment, right? And then line segment, even you measure from F to E or E to F, they are going to be same. But the order of writing similar triangles is very important, but the line segments now doesn't have any sense, right? Writing here EF or FE doesn't make much sense, or doesn't make any very big mistake. And then the last thing is then side AC and side DE is also in the same proportion, right? So what can I say about the sides now? So these are in proportion, so which is also same as saying side criterion. So if the corresponding sides of two triangles are in proportion, then the triangles are similar. So if AAA holds true, then SSS also will hold true, or if SSS hold true, then AAA also holds true. So it is enough to say in two triangles, either all the three angles in those two triangles are equal, or you can simply say that the sides of these two triangles are in the same proportion, which means that the angles of the two triangles are also going to be the same, right? So here I say by AAA criterion I have this proportion, right? By AAA criterion I have this in proportion, right? So say for example I am not at all given about the angles and I am just given only the sides, right? I am given only the sides, that this triangle ABC and here is a triangle DEF, and I am only given that triangle, sorry, AB by DE and AC by DF and BC by EF. I am just given this only, right? Then from this I can say that these two triangles are in similar to each other, that is triangle ABC is similar to triangle DEF, sorry, DFE I guess, ABC, sorry, yeah, DEF. But from this I can surely say that this actually implies that angle A equal to angle D and angle B equal to angle E and angle C equal to angle F, right? So here's the deal: if the angles of the two triangles are equal, I can say that those two triangles are similar, and those two triangles are similar, then the sides are also in proportion. That is point number one. Now point number two is that if two triangles side are in proportion, which also means that those two triangles are also similar, which again brings us to the angles of those two triangles are also same, right? Now let's also think of the other criterion, which is also famously called as the SAS criterion, side angle side criterion. If two sides are proportional and the included angle is equal, then the triangles are similar. So say for example I have a triangle, let's name this triangle as DEF and this triangle as LMN. Break the what to say criteria, or break the conventional rules of just naming ABC or PQR, whatever. Fine. Now, so what are we given now, right? Now we are given that two sides are proportional, right? So let's take that, let's assume that this DE and MN and DF and LM. Okay, so now let's say these two sides of these triangles are proportional, so which means that DE by MN is now equal to DF by LM. And note the point that if I start with the triangle DEF, I always start with the side of the triangle DEF at the first place whenever I am writing proportions. I can't say that this DF by LM can also be written as DLM by DF, right? So make sure that you start make sure that you start with the sides of the triangle of these same things, right? So if at all I start with DEF, I should always start with DEF triangle. Yes, coming back now, this triangle, in these two triangles I have DE by MN and DF by LM are in the same ratio, or they are proportional. So we are given and the included angle is equal. So what do you mean by included angle? So included angle are nothing but the angle which is being included by these two sides. So here DE and DF is included here, and then MN and ML actually includes an angle here. So now what I say that I am given that these two triangles are being given with these conditions that two sides are proportional and angle D and angle M are equal. Now if at all I am given this conditions, then I can also say that these two triangles are similar, right? So this is another condition for this. The proof of this is beyond the scope of the video, but if at all you request, I can give it, right? So now how do I write the similarity criterion for this? Because I said the order of writing a similarity criterion also matters, right? So let's start with this triangle DEF. So I'll just write simply triangle DEF is now proportional to, I don't know how to write this, so let's start. Let's look at all cases of naming this triangle. So I can name this triangle as MLN, right? I can name this triangle MLN. I can also write this triangle as MNL, right? MNL, or I can also write this triangle as LNM. These are all the three possibilities, or I mean not all the three. I can have 6 possibilities, but let's see what could be done, right? So I'll start by this one. So just how to write the similarity criterion, since I said the order is a very big matter now. So yeah, so is DE is the same proportion as ML? I guess not, because DE and MN are in proportion, right? So this way of writing is wrong then, right? So what should actually happen is that I should write DE. So in place of DE, I should have either MN or NM. So I'll start with MN. So the other letter is going to be L. So let's now try in this area. So now DE is same as MN, which I had now here, right? And I should have DF is also same as LM, right? So DF should be in proportion to LM according to this criteria given. So let's try here. So I have DF, right? I have DF, and let's see whether I have LM here. Yes, I have LM, right? ML or LM. So now with this and then we also have this angle D and angle M are equal. So angle D and angle M, yeah, both are in the first place. So yes, what I have written here is now correct. Angle DEF is similar to angle MNL. So what do I insist here at the most is that the order of writing similar triangles also matters. We can't just simply write DEF is equal to MLN or in any other order except MNL, right? Yep. So hope this gives you at least a small understanding of similarity of triangles, and by the next video I guess we'll be solving some nice problems on similarity of triangles. But in conclusion, what have we learned today from this video is that we have learned these 3 criteria. So AAA Criterion of saying that 2 triangles are similar, and SSS criteria of saying 2 triangles are similar, or SAS Criterion of saying 2 triangles are similar. So what do you mean by AAA Criterion? So if at all I say 2 angles of 2 triangles are equal, then I can say those 2 triangles are similar. And SSS Criterion is of similarity is nothing but if at all 2 triangles side are in proportion, then I can say those 2 triangles are similar. And if at all I say that in any 2 triangles 2 sides are proportional and the included angle of those 2 sides are equal, then I can say those two triangles are similar. So we end this video here, and we'll look forward to solve some problems in the next video. Until then, take care, bye bye.